Hello everyone. Today I'm going to explain you about you know lots of things. I'm going to explain you how the Milvus and our knowledge-based concept interacts with each other, and we are going to explain you about the ingestion part also. So stay tuned. So what when we talk about Milvus, we connect with the relational database management system. So Milvus have a concept of collection which is similar to of RDBMS table, and both have the similar schema. Okay, basically the idea of schema, not similar schema in a way. You can check out the code. I've shared you the source code, and basically the collections which we are creating in. Okay, so basically those collection which has I wanted to mm, describe you three important things about that collection, which is that we are going to have a ID primary key, but that primary key is not auto generated because we wanted to do upsert operation, and that's why we are not auto generating IDs. Another thing is that we are going to do hybrid searching. The reason to do hybrid searching because we wanted to be accurate, and that's why we are doing hybrid searching. We can't rely on single index, and that's why we are using BM25 sparse based searching index, and we are also going to use three different kind of indexes based on user decision, because the collections are going to be of three type based on user requirements. See, if user scale is below 1 million vectors, they are going to use flat, because the flat index is it's better managed with the smaller data sets, because it could be stored into memory, and that's why it's balanced between the latency and the accuracy both. But as you scale, when you scale from 1 million vectors to 10 million vectors, the range is within that, then you need to use graph based indexes, and for that, that's type described as HNSW, and that index help us doing graph based searching, and which is very fast because those graph entities are being stored in the memory, and due to that it's very fast. The third method which which here it is described, which is IVF SQL, because it's what we call inverted file system, where you have clusters of silos of clusters, and you store your vector dimension into that cluster, and you have those groupings, and searching occurs within that group, and group actually points and aggregate all the other dimension, and build a whole contextual output. The accuracy here is kind of scale down between 85 to 90%, because the scale is bigger, which is 10 million plus vectors, but at the same time you need to handle the scale, and you have to balance the trade-off. So to handle the scale, we are scalar quantization, we are like basically compressing the vector dimension, which is known as scalar quantization, and that is the procedure through which this has been done, and that's the part of it. Now moving forward, I've described everything how we have uh, built this, and this is about the Milvus thing. Now another thing which I want to share is, see, this is a remote operation. When we create a collection, it's a remote operation. Now we don't want user to wait while we create a collection. Instead, we wanted that we have a pools of collection already ready, and whenever a user creates the knowledge base, those collection would be already assigned to knowledge base. So basically, whenever the application starts, it already has a pools of collection. It has five type of collection, five types of flat collection. It has five types of HNSW collection, maybe three types of IVF SQL, because there are less and less users who need IVF SQL collection, because we are handling for smaller enterprises. So that's why we have kept a smaller pool, because you can change the pool anytime. There is a constants. You can change it and you can configure it, the pool, and so there is a provisioner for that. So the how provisioner works is like, you have this provisioner manager, and we have the state of collection in database, and we have Milvus, and we have this whole application here. Okay, so initially when application is starting, it queries the database that what's the state of the collections, what's the state of collections, and we have and we get those states of collection, and inside the application logic we have predefined the collection minimum threshold. And so application logic checks that the state of collection is fluctuated below it. If it has gone below the threshold, then application would create that, remote collections, and based on that those collection would be created, and the state would then be updated in the database so that collections pool remain the consistent ecosystem. So this all has been managed by the provision manager logic. It's all the work of provision manager, which has been designed to manage this all, the maintenance of it. But this is about the time when we are initializing the application. What is when the application is running, and that's the tricky part to solve, because that's where the concurrency comes in. At the same time you have to handle multiple requests coming in, and anything can happen. So for that we have managed a queue, a local management queue via a library, and based on that what we are going to do is we are triggering a queue based communication. So how this works, let me show you. Remove everything. So basically whenever a user request comes in, there is a queue setup, okay, which is the locally queue, and which has been scheduled using AP scheduler. This is the library which is basically useful for queue management, I guess so. Let me re-verify that that is the library I've used. So I've used async IO. Okay, my bad. I'm really sorry for that. I've not used AP scheduler. I've used AP scheduler for scheduling the jobs. I've used async IO based queue for the communication. That is because the communication is asynchronous, because the reason for that is client request, concurrent request could be coming anytime, and we have to handle the nature of the asynchronous communication here. So whenever a client request comes in, whenever the client request comes into server, not the provision manager, my bad. When the client request comes in for the provision manager, to the application about the collection requirement, whenever knowledge base are created. We already know that we already have a pools of collection, because during the initialization of application, we know that those certain threshold of collections we already have. So whenever a creation of knowledge base request comes in, provision manager, the application, the endpoint logic of that handler of that endpoint, what it will do, it would trigger a message in the queue, and to create a certain collection. That means the collection has already been assigned, and create a certain collection. That could be IVF, HNSW, whatever the collection pool has been missing about, and it will trigger that, and this queue is already part of the application. Okay, sorry for my bad diagram. and that queue will publish it to provision manager to provision a new collection, and it would do so, and it will change the state of the collection. Okay. At the same time, earlier when the endpoint handler assigned, it does change the state of collection, and then that this process occur. I missed this point, but whenever a knowledge base has been created, the endpoint handlers maintain the consistent state of the collection. It deducts that, but basically it's not directly deducts that. It tells provision manager that we have used this collection from your provision. It's like an inventory management, that we have used this collection from your provision, and provision manager would read it from state of collection, but at the same time it would trigger via provision manager this queue. Okay, and that would receive to the provision manager that the state of collection needed to be reconciled, and it would start a reconciliation process. But one thing is that is confusing to a lot of people, that why we have used queue. Okay, that's because we need to handle the asynchronous communication and concurrency, because there are like multiple concurrent requests coming in. Now if we do that, and there's no consistent management of the system, like how much pull is required, because endpoint would publish message to the queue and queue will receive it. So the reconciliation process is like, whenever a concurrent requests are coming in, endpoint handler will say to provision management, assign me the collection. Provision manager will handle it, and it would handle the state of the collection. But only once, whenever the queue is holding only the one message, it's holding only one message at a time. Why? Because we don't wanted to overload the provision management to create a state of collection, because provision manager already knows that it has certain missing collection, because that has been triggered by endpoint handler. Endpoint handler asks from provision manager that I need this collection, and provision manager will give endpoint handler that collection, and it would maintain that state of record in the database, and it knows that these collections are missing, but we have to trigger provision management to reconcile. So that's the one thing you do, but you don't do it again and again, because if there is a scales of traffic, you don't want it to overload provision manager that we have to create the collections. It knows, and it would do reconciliation, because the state of truth is the database. It's kind of complex in the way I'm explaining, but if you review the code, it has been like simply hydrated into marinated into this concept, and it's very simple concept. It's not rocket science, and people would think that this is like a complex system within a single instance of application. We have to do it because we are building for small scale. If we are building for large scale, we would decouple everything, and we would maintain decoupled architecture, but that would be harder, because the source of communication needed to be managed. The schematic communication we need to manage between provision manager and queue. But if it's within the application, then it's very simple to manage the coupled architecture, because they all know the context of the communication, and they have the similar schema we could define within that application. So that's how the provision manager works, and that's how we create the knowledge base. Let me show you in the demo, and let me run it. It's not running right now. So we have started the collection, the whole application. This is taking some time, but let it just start it. Okay, it has started. Let's just expect the logs of. Okay, so our application has been started. Let's just see. The duration of our token is, I guess, 24 hours, maybe. Let's just check. And so let me generate the token. Talking about the admin API. Anybody could create those knowledge base because it's multi-tenant system. And so whenever we create a knowledge base, we need to mention the type of it and the category of it. Right now we are going to build flat because we're not going to have a large data set, that's why it's going to be very simple. So let me create it. Okay. So it's very fast, but see, it's like very fast. It just took 41 milliseconds. It's just, it's just changing the state in the database that this entry of the knowledge base has this Milvus collection. But because we have already created those Milvus collection, we have those pools of collection. Take an analogy of database pool collection. Database have tens of, 20s of those collection pool open for the connection, and similar to that we have it in Milvus where we have multiple collection, 5 types of flat, 5 types of HNSW, and 3 types of IVF SQ8, which are already predefined and pre-created in the whole application, at the whole application level, not at the user level. That also I wanted to mention. And whenever we just created this knowledge base, and I want to show you the logs. Okay. You can see we received it, and you can see which I talked about the queue from these logs, event driven trigger received. Okay, so what that does mean, because we created a knowledge base that triggered to the queue, that we need to reconcile the index, the collections in the provision manager. Okay, and so basically we are triggering that, and during that, we are going to have missing sets of collections, but to maintain that quickness to reconcile the lost collection, we would trigger it. But when there are multiples and multiple concurrency requests coming in, then we need to care that we are not overwhelming the server itself, we are not overwhelming the provision manager, and that's why we are using only one message at a time. And so if concurrently multiple messages goes to that queue, those messages are being dropped, they are not being received. So we are not overloading the provision manager, but at the same time, via the endpoint handler, we are triggering the provision manager that we need a reconciliation process, because a collection I have taken and you need that collection. That's one thing. And provision manager itself has a management system that it does a periodic reconciliation. So that's how we are going to manage those collections, and we are going to have a hot collection so that user experience is like badass here, because we can quickly create those knowledge base and user don't have to wait that Milvus should be getting us back our collection, creating it, because it's a long running process. And that's how we are improving the user experience of this whole thing.